Okay, let's unpack this. We're diving deep into a topic that's, well, it's absolutely shaping the future of technology, economics, global influence. Everything, really.
We're talking about the intense, accelerating competition between the United States and China in large language models, LLMs.
Right, LLMs. Think of these as the engine of cutting-edge AI right now.
Exactly. These systems can understand, interpret, generate just vast amounts of data. It started with text, but now images, audio, multimodal is the term.
Yeah, it's moving fast. And you've supplied us with quite a stack of sources here, articles, research, analysis, giving us a snapshot of where things stand in this crucial race, as of early 2025.
Exactly. So the mission today is to go through all this, pull out the really important insights for you, give you a shortcut kind of to understanding the dynamics here.
Who are the key players? What tech advancements are they actually making?
Yeah, the roadblocks too. And honestly, what does winning even mean in a game moving this fast? It's not simple.
Okay, let's jump in. Let's see what these sources are telling us about who's leading, where that performance gap might be closing maybe faster than some thought.
And what other factors, beyond just the models themselves, are driving this whole thing?
So first off, why does this matter so much? Why are LLMs suddenly at the center of this huge global competition?
Well, the sources are really clear on this. They see LLMs as genuinely transformative technology.
Transformative how, exactly?
The analysis points to potential reshaping of, well, almost everything. National security strategies, economic frameworks, even just how we interact with information day to day. It could be fundamental.
It's that capability, isn't it? The speed.
Yeah.
Ingesting, interpreting, generating huge amounts of data.
And across modes now, images, audio, like we said. That makes them pivotal tools. You can use them for economic policy analysis or, accelerating scientific discovery. Big applications.
And this all ties into the bigger picture of artificial general intelligence, AGI.
Right. Whether AGI is just around the corner or further off, the potential for systems with near-human cognitive abilities, that's seen as having immense stakes for security, for economic growth.
We're seeing figures in the sources, projections of AI, contributing trillions to the global economy.
Trillions, yeah. That kind of potential value just fuels massive investment, creates this real sense of urgency. You can feel it in the analysis.
Okay, so let's look at the arena, the players. The sources detail a pretty fascinating landscape, both sides of the Pacific.
Yeah, starting with the U.S., the picture painted is one of incredible diversity. It's largely driven by private investment.
You got the big names, obviously. OpenAI, their GPT series keeps evolving. The sources mention 4.5 and those specialized O models.
Then Google DeepMind with Gemini. You have the big one, 2.5 Pro, but also the faster, lighter ones like Flash and Light, plus their open source Llama family.
Anthropic's in there, big focus on safety, controllability.
Yeah.
Their Claude series, like 3.7 Sonnet. The analysis mentions that extended thinking mode feature.
Very interesting. And Meta AI, of course. A huge force, especially pushing high-performance open source with Llama. The sources talk about Llama 4, mixture of experts, native multimodality. Big plans there.
And it's not just them. The list goes on. XAI with Grok 3 using real-time data.
Mistral AI, European technically, but, widely adopted globally. Amazon's Nova models for enterprise. Cohere focusing on RAG.
Microsoft with their smaller, efficient Phi series. And NVIDIA. Not just chips, but foundational models too, like Nematron.
It really is a crowded field in the U.S. Super innovative. Lots of different approaches.
Okay, now flip to China. The sources show incredibly rapid progress there, and often with strong government backing. That seems key.
Definitely a factor. Key developers mentioned include Alibaba with their Qwen series, noted for using both traditional and MoE architectures, even these unified thinking, non-thinking modes.
DeepSeek AI. They've gotten a lot of attention internationally, right, for powerful open-source MoE models.
That's right. DeepSeek v3 R1, often highlighted for efficiency. And Moonshot AI's Kimi K1.5, noted for strong multimodal support, impressive long context window.
Others mentioned Baidu's ErnieBot, that's been around a while. Zippu AI, GLM4+, known for multilingual stuff. ByteDance with Dubao 1.5 Pro.
Which uses a sparse MoE structure, yeah.
Yeah.
Then 01.AI's Yai Lightning, efficient models. Fudan University's MOSS project, Minimax.
Even companies like Hanhai Foxconn developing localized models. Foxbrain for traditional Chinese, based on Llama 3.1 apparently.
Just listing them out shows the scale, right? The breadth of the effort in China. It's a serious, diverse group of developers on both sides.
Okay, now the really juicy part. The performance showdown. Historically, U.S. models set the pace. The sources acknowledge that, but they all emphasize how fast China is accelerating.
The performance gap, it's narrowed. And significantly, you can really see this in trends from places like Chatbot Arena.
Chatbot Arena, right. The crowdsourced leaderboard.
Yeah. The score difference they track between top U.S. and Chinese models, it apparently plummeted. Over 100 points in January 2024, down to just 23 points by February 2025.
Wow. 23 points. That's basically neck and neck in perception almost.
It's a huge drop in just over a year. The Stanford AI Index report highlighted this too. It noted Chinese models reached near parity on some established benchmarks, MMLU, Human Eval, during 2024. That was a big leap from 2023.
So not just catching up slowly, but making significant strides.
And then the release of models like DeepSeek R1 in early 2025 that really underscored this narrowing gap, prompted a lot of reassessment, of the whole global picture.
And what really jumps out from these sources is that China isn't just generally getting better. They seem to be pinpointing specific areas.
Exactly. Areas where their models are particularly competitive or sometimes even outperforming. Coding, mathematics, multilingual applications, especially Asian languages.
The examples cited: DeepSeek V3 R1, Moonshot AI's Kimi K1.5, showing really strong results on tough math benchmarks like Math 500, AM.
And coding tests, too. Codeforce's Live Code Bench. It suggests a very focused effort in those domains, not just trying to build a general model, but excelling in specific, valuable skills.
But the analysis also pumps the brakes a bit on benchmarks, right? Gives a more sober look.
Yeah, absolutely. They point out the limitations. Saturation is a big one, especially in older texts like MMLU.
Meaning the best models all just max out the score.
Pretty much. It makes it hard to tell the very top models apart using those older metrics. They're just too easy now for the frontier systems.
So what's the solution?
Well, the saturation has spurred the creation of new, much harder benchmarks. Things like GPQA Diamond, AM 2025, SWEBENUM, Brind, even one called Humanity's Last Exam. Quite dramatic.
Sounds intense.
They're designed specifically to differentiate these truly frontier models, the ones pushing the absolute limits. So yeah, the race is tightening on older benchmarks, but the goalposts are definitely moving to these new, harder challenges.
Okay, so underlying all this performance improvement,
Yeah.
it's got to be the architecture, right? The engines driving these models.
Fundamentally, yes. Both sides are aggressively innovating in the core model architectures, pushing frontiers.
And a key trend discussed everywhere in the sources seems to be mixture of experts, MoE models.
That's a big one. It's an architectural technique. Lets models scale much more efficiently instead of the whole giant model crunching on every single input.
It sends the work to specific experts, little subnetworks.
Exactly. Selectively routes the input, makes it much more computationally efficient, especially for inference. We see it in the U.S. models Meta's Llama 4, Mistral.
And heavily used in China, too, you said. DeepSeek V3, R1, Alibaba Qwen 3, ByteDance Dubao 1.5 Pro.
Yep. And the analysis even notes interesting variations, like DeepSeek's methods for load balancing between the experts, or Qwen 3's specific ways of segmenting them. Lots of subtle innovation there.
What about attention mechanisms? That's always crucial for LLMs.
Critical, both for efficiency and for handling longer context, remembering information from further back. DeepSeek V3 uses something called multi-head latent attention, MLA. Noted for reducing the memory footprint needed for that KV cache, the model's short-term memory, basically. Alibaba Qwen 3 uses QK norm for more stable training.
And Meta's Llama 4 Scout. That reportedly huge 10 million token context window. That's partly attention tricks.
Seems like it. Clever techniques like interleaved attention layers are mentioned. A 10 million token window. That's just incredible, a massive leap.
We're also seeing this move towards what sources call thinking architectures, or hybrid reasoning.
Yeah, it's about designing models that can perform more explicit, multi-step reasoning. Not just pattern matching, but actually working through a problem.
Examples.
Google's Gemini 2.5 Pro is described as a thinking model. Anthropic's Claude 3.7 Sonnet has that extended thinking mode for complex tasks.
And China's right there, too.
Oh yeah, Alibaba Qwen 3 apparently has unified thinking non-thinking modes. ByteDance Dubao 1.5 Pro, engineered for advanced deep thinking, enhanced through RL techniques. It's a clear trend.
Multimodality, too.
Yeah.
Integrating text, image, audio. Seems like table stakes now.
Rapidly becoming standard. Native multimodality, early fusion. Meaning the model handles different data types from the ground up. US leaders. OpenAI's GPT-4o, Google Gemini 2.5 Pro, Meta Llama 4 using early fusion, making huge strides. Moonshot AI's Kimi K1.5 trained jointly on text and vision. Strong capabilities also highlighted in Alibaba Qwen, ByteDance 1.5 Pro, Zhipu AI GLM4V. It's not an afterthought anymore.
Any other architectural innovations jumping out?
The sources mention things like DeepSeek V3's multi-token prediction during training, trying to predict several words ahead, not just the next one. And Meta's Llama 4 reportedly using FP8 precision training.
Lower precision numbers for speed and memory.
Potentially, yeah. Using 8-bit floating point numbers instead of 16-bit. These details just underscore the sophisticated research happening in parallel, both sides.
Okay, but all that amazing architecture needs fuel. Data. Let's step back from the blueprints and look at training data and the whole ecosystem around these models.
Data is absolutely critical. The sources talk scale. Of course, the numbers are just mind-boggling. Meta Llama 4 noted as pre-trained on over 30 trillion tokens. Alibaba Qwen 3, roughly 36 trillion.
Trillion, wow.
But, as the analysis points out, it's not just volume. Quality and diversity are paramount. You need the right kind of data.
So what are the strategies, U.S. approaches?
Seems very diverse. Drawing from vast public web data, sure, but also proprietary datasets, partnerships, custom-curated stuff. Meta Llama 4, for example, reportedly made a big push on multilingual data, pre-training on data covering 200 languages.
And China. Also emphasizing diversity.
Yes, but a key strategy highlighted there is the strategic use of synthetic data.
Yes.
Generating data specifically for training.
How so?
DeepSeek V3 added substantial amounts of synthetic math and court examples. Alibaba Qwen 3 used models to extract text from PDFs, generate math code data. Moonshot Kimi K1.5 uses a curated multimodal corpus, but also synthetic data, especially for math, knowledge, code in later training stages. It's a way to target weaknesses or boost specific skills.
Interesting. And beyond the initial pre-training, alignment is huge, right? Making sure these things do what we want.
Yeah. Crucial. Reinforcement learning, other post-training techniques. Aligning them with human intent, safety goals. U.S. approaches mentioned. OpenAI still using RLHF reinforcement learning from human feedback.
Right.
Meta's got a revamped pipeline, supervised fine-tuning, then online RL, then DPO, direct preference optimization. Google focusing on improved post-training for Gemini.
And China's approaches.
Also using advanced techniques. Moonshot Kimi K1.5 scaling up long context RL. Alibaba Qwen 3's multi-stage post-training includes specific RL steps for math and code improvement. It's a very active area of research.
Okay, zoom out again. The broader ecosystem. Talent, investment, infrastructure.
Talent is obviously key. The sources estimate a really deep pool of AI engineers in the U.S., maybe 150,000 to 200,000. Plus, the U.S. attracts global talent, has leading universities.
China's building its talent pool.
Aggressively. Building domestic programs, recruiting abroad. Though some analyses question if they have enough top-tier talent yet for the scale of their ambitions, it's a challenge.
Investment. This seems like a big difference here in the sources.
It is, at least in private investment. U.S. leads significantly there. $109.1 billion in 2024 versus China's $9.3 billion cited in one report. Huge gap in VC funding.
But China have government funding.
Very substantial government-led initiatives, yeah. The Bank of China plan mentioned, earmarking $138 billion over 5 years just for the AI industry. Different model, but potentially very impactful state backing.
Infrastructure, compute power, labs.
U.S. benefits from top universities, extremely well-funded private labs and the big tech companies, and just massive compute resources. Government projects like the NRR pilot, plus the colossal spending by tech giants on data centers.
Okay, this leads us nicely into the geopolitical chessboard. The factors beyond the tech itself that are shaping this whole race.
Yeah, this is where it gets really complex.
National AI strategies seem like the obvious starting point. U.S. versus China approach.
The sources characterize the U.S. approach as promoting innovation, but also focusing on safety, responsible regulation, like through Executive Order 14110. NSF funding drives it too.
China's strategy.
More centralized. A strong push for self-sufficiency, laid out in their 2017 development plan. Direct government funding, strategic direction. Both countries are also dealing with potential regulatory impacts. That's something to watch.
And then, the chip war. This comes up constantly as a major factor, especially for China.
Arguably the most significant external challenge for China, yes. U.S. export controls on advanced AI chips. NVIDIA's H100 is the key example, and the manufacturing equipment needed to make them. That creates a real bottleneck for training the biggest, most powerful models at scale.
So how is China responding?
The analysis says it's multi-pronged. One, stockpiling chips they could get. Two, focusing intensely on algorithmic efficiency, making models run better on older or less advanced domestic chips.
Smarter software to compensate for less powerful hardware.
Kind of, yeah. And three, a massive aggressive drive for domestic chip production. Huawei's Ascend chips, Siki reportedly targeting 7mm, even 5mm manufacturing processes.
But where are they now with domestic chips?
Estimates in the report suggest they still lag U.S. state-of-the-art by maybe 4 years or so. And a huge related challenge is building the whole software ecosystem around those chips, something competitive with NVIDIA's CUDA platform, which is so dominant for AI development. That's not easy.
Another strategic dimension is open source versus proprietary models.
Right. The U.S. has a mix. OpenAI, Google lean proprietary. But Meta, with Llama, Mistral, those are hugely influential open source efforts.
And China. The sources mentioned a trend towards open sourcing powerful models.
Yeah, interestingly, models like DeepSeek R1, Alibaba Qwen, the thinking seems to be strategic. Foster their own domestic ecosystem, accelerate innovation internally, maybe counter Western dominance in the space, and crucially build talent by giving developers powerful tools to work with.
And the performance gap between open and closed models is narrowing, you said.
It seems to be, yeah. Which makes that open source strategy potentially very powerful.
Okay, one more key factor mentioned, especially for China. This focus on applications and small language models, SLMs.
This is highlighted as a really smart strategic response, partly to the chip constraints, but also leveraging their huge domestic market.
SLMs, smaller models, right, tens of billions of parameters, not hundreds or trillions.
Exactly. They're more cost-effective, faster to deploy, potentially more accurate for specific, narrow tasks, great for edge computing, IoT devices.
So China's focusing on building specific AI applications.
Seems like it. AI tools for video editing, smart agriculture, companion robots, things tailored for specific industries. It creates this hybrid ecosystem. You still have foundational models, but a strong emphasis on specialized SLMs for localized, domain-specific, or cost-sensitive uses.
So the idea is maybe the base model has become a bit commoditized.
And the real value, the competitive edge, shifts to that application layer. Who can build the best solution for a specific problem using these AI tools? That seems to be a core part of the strategy.
Okay, so bringing it all together, players, tech, data, geopolitics. What does winning this LLM race actually mean? It sounds like it's definitely not just about benchmark scores anymore.
The sources are unanimous on that. Winning is, well, it's multifaceted. It's about market share, real economic impact, how deeply AI gets integrated into society, global influence, the pace of innovation, success in actual use cases.
And that overall AI diffusion capacity, how well a country actually uses AI.
Exactly, that real-world application, value creation. That's highlighted as absolutely key, moving beyond what benchmarks alone can capture. The analysis really hits on the limits of current benchmarks, the saturation problem, the need for metrics on real-world performance, safety, efficiency, task success.
So what are the expert predictions looking like based on these sources? Where are things headed?
Well, China is seen as highly likely to match U.S. capabilities on some benchmarks during 2025, especially in those targeted areas like coding or math.
But the U.S. likely maintains an edge elsewhere.
Generally expected to keep an advantage in overall compute capacity for frontier training, and perhaps in that broader AI deployment and integration, the diffusion capacity across many industries.
What about longer term, say 2030?
China is projected to be a very close second globally by then, potentially outperforming in specific sectors or regions. But the sources also caution against underestimating China's resilience, their potential for breakthroughs, especially with that focused, state-backed approach.
And the race itself is changing, shifting focus.
Yeah, increasingly seen as shifting from just pure foundational model innovation towards a competition over infrastructure compute, data pipelines, and adoption, actually using the AI effectively.
And 2025 specifically.
Predicted to be a year where we see more commoditization of base models, a big focus on operationalization, making models cheaper, more efficient, fine-tuning those SLMs for specific jobs. Practicality takes center stage.
So the future trajectory sounds like a single winner is unlikely.
Very improbable, according to the analysis. A multipolar LLM world seems much more likely, different strengths in different places.
The U.S. might lead in.
Frontier research may be the biggest general-purpose models, given their strengths.
And China.
Likely to excel in rapid, cost-effective application deployment, those specialized SLMs we talked about, and AI integration tailored for their huge domestic market. and potentially exporting those solutions, especially to the global south.
Other countries finding niches too.
Exactly. It won't just be a two-horse race indefinitely. Other nations, regional blocs, will likely develop their own specializations.
So if we want to track this evolving race, what are the key indicators the sources say we should watch?
Things like, obviously, China's progress in advanced semiconductor manufacturing, hard metrics on AI adoption and economic impact in both countries, the flow of AI talent, where are people going, shifts in global market share for AI products.
The health of the open source ecosystem seems important too.
Definitely. And government policies, standards development, and, crucially, how benchmarks evolve alongside better metrics for real-world performance. We need both.
Okay. So what does all this mean for you? Listening in, this deep dive really shows it's a dynamic, incredibly fast-moving, complex competition.
Yeah, it's pushing AI innovation at an absolutely unprecedented pace.
And that gap between the U.S. and China, it's narrowing rapidly.
Yeah.
Factors like chip access, government strategy, the ability to deploy AI in the real world.
Those are just as crucial, maybe more so now, than just raw model performance on a test.
We're likely heading towards that multipolar world where different countries excel in different aspects of AI. Not one winner takes all.
And here's where it gets, I think, really interesting looking forward. The analysis suggests as those foundational LLM capabilities become more widespread, maybe even commoditized, the true value, the real competitive advantage, might increasingly shift. Not just about building the biggest model, but about leveraging local data, understanding specific market needs.
And building specialized AI solutions, tailored for specific industries,
Yeah.
specific regions.
Exactly. That's the potential shift. How will that move towards specialized, maybe more localized AI impact the global tech landscape that, you interact with every single day?
That is definitely something worth thinking about.